What's up, everybody? Algebra 1. We are going to move into the EQ, which is how can I find or choose the right method to solve systems of equations. You might first be asking, why is Mr. Townsend wearing sunglasses? Well, it is beautiful outside, and I was wearing my sunglasses, and they're prescription, and I don't have my other glasses, so you're just going to have to roll with me. Basically, we've got 4 equations, and we've learned 4 different ways to solve systems of equations. We've learned how to do it graphing. We've learned how to do it using tables, XY tables. We've learned how to use the substitution method, and we've learned how to use the elimination method. Okay, they all have their advantages, and so when the equations are set up in different ways, that's when we'll use those methods. So right now I'm going to put up 2 quick slides to just show you what each method, how you use it, and then when is the best time to use each of those. All right, I hope that you took notes and that was helpful. So just remember, when graphing, if both equations are in slope-intercept form, graphing is an appropriate method to use. Normally, if you've got like one of the slopes is a fraction, it's easier to graph than to use a table, just because you've already got your rise over run included in that slope-intercept equation. Table, if both equations are in slope-intercept form and the slope is an integer, so both of them are integer form, whole numbers, input-output tables may be the best method, just because it's very simple. You just plug the number in for x, you get an output. Very simple, very, very easy. Substitution, if you have the 2 slope-intercept equations, or you just have 2 equations, and one of them is with the variable isolated on one side of the equation, substitution is easy because you've got y equals this, and you can just plug whatever it is into the y in the other equation. Very simple, use that. Now, if you have 2 equations in standard form, okay, where you got x and y on the same side, and they're lined up in columns, elimination is probably the best way. So we've got 4 problems here, and I'm just going to go over which method I would use for each of them. Doesn't mean you have to, because you're going to be able to choose your own, but let's just go over it. Okay, so this one right here, we've got x and y, and we've got your constants on one side of the equation. So they're lined up in columns, and then you've got -2 and +2. So this would be a perfect opportunity to use elimination. I'm not going to solve, but the reason why elimination is because I could just add these 2 columns up. This would cancel out. I'd have 4x equals 16. X equals 4 right there. Then I can plug it into the other equation. I got my x and my y. Simple. Okay, so when they're lined up vertically like this, use the elimination method. Okay, over here we've got y equals 2x minus 3. So y is isolated all by itself. Okay, and then we've got 4x minus 5y equals -1. So we've got a standard form, and then we have a slope-intercept form. What I would use for this is I would put y. I'd use the substitution method. I'd just go right here, I'd plug that in right there, and I would use the substitution method on this one. Because if I was going to do any other method, I'd have to get this into slope-intercept form, which is a bunch of steps. Right how it is, I can just go right into substitution method, no problem, because I have one of the problems isolated into a slope-intercept form. So y equals something, very simple, very easy. All right, moving on to number 3. We've got y equals 1/3 x, and then y equals 2x plus 7. So both of them are in slope-intercept form. Both of them have y isolated on one side of the equation, but the one thing that we see is that this one has 1/3, which is a fraction. That might be tough for some of you to put into a table, and it might get a little confusing. So what I would do is I'd just graph this. This one, we're going to start at the origin, and we're just going to go up 1/3, up 1/3. That's simple. Okay, that's an easy way to graph. And then here we're starting at 7, and we're just going up 2. Okay, so that would be something that I think you can definitely do. That'd probably be the best one, is just to graph this one. So let's graph. Okay, and then the last one, we've got y equals 5x minus 9 and y equals 2x minus 3. Those are 2 slope-intercept form where we have the y isolated on one side of the equation, and it just seems to me that those would be very easy to throw into a table and see where the solution is. So I would use the table method on this one. Okay. Now, you might only feel comfortable with graphing. You might only feel comfortable with substitution. It doesn't really matter. Whatever you're comfortable with, you do. But I'm just saying on each of these, it will eliminate work for you if you feel comfortable with all of them. And you just kind of can figure out which way is the best and use that method that's the best. Last thing we're going to do on this lesson is I want you to write a sample of a system of equations that would be best solved by elimination, graphing, and substitution. So what I want you to do is pause the video, and then I just want you to write a system for each of these that would be best for each of those, and then I'm going to do one afterwards. So make sure to pause the video and write a system for each of these. So we're going to start with elimination. I like to use red for elimination. I don't know why, but here we go. So we're going to want two equations in standard form, okay, where x and y are on the same side. So let's go 10x minus 3y equals 12, and then maybe 5x plus 3y equals 3, okay? So that's probably the best way. You got your x's and your y's lined up vertically in columns, and then you have your constants on the other side of the equation. Okay, graphing, let's use a different color here. For graphing, I'm going to make sure we got 2 in slope-intercept form. So we've got 2 in slope-intercept form, and I just made them both fractions, so we already have the rise over run for those to graph easily. Okay, and then the third one, substitution. This is where you'll probably have 1 in standard form and 1 in slope-intercept form, with the y isolated or the x isolated on one side. So let's go y equals 3x minus 1, and we'll go, 5x minus 2y equals 12. Okay. So you've got your standard form, you've got your y equals 3x minus 1. You could easily plug that into y and then solve for x and y. So that's all you got to do. You just feel comfortable with the different methods. Maybe go back, do make sure you master that homework, and then you can recognize what the best method is to solve systems of equations. I hope this helped. If you have any questions, make sure to email me, maybe comment, whatever you need to do. But I hope you're doing great. Hope you're enjoying the sunshine. Have a great day.